Let's get started here. Hope my screen is all right. So welcome, and yes, thanks for joining my session. And this is event-driven architecture on Azure. Let's get started. And what I want to talk about today, I wanted to talk about and put focus a little bit on the nuances of event-driven, some of the really confusing concepts that makes it hard for us developers to start building applications on the cloud using event-driven patterns. And then we're going to have a quick look at some of the different Azure messaging services that we can use to implement this architecture and how do they compare to each other. And then I'm going to go with a little bit of a demo with some very simple code just to illustrate how do we really implement the event-driven architecture in a .NET Core application and what kind of Azure services we can use. And then if we have time, we can go through a list of some of the pitfalls that we need to be aware of when building event-driven applications. So a little bit of introduction about myself. I am Marilag Dimatulac, Svennevig. I'm also a Filipina tech entrepreneur. I've been living in Scandinavia for so many years now. And I am a cloud architect, but about 6 years ago, I was crazy enough to start my own tech company together with my partner. It's called Device. But lately, I really love talking about anything about cloud architecture and app modernization. That's why the previous talk from Jonah is really interesting, because I've also been through some of those really hard, painful journey for migrating to apps to cloud. I also like talking about different design patterns, DDD, and such, because I'm also very passionate about developer wellness. And I do think that good architecture is a major contributor for our wellness as developers. Also an Azure MVP, co-founder of an organization called ulap.org. It's a volunteering organization that helps underserved youths kickstart their careers in cloud by giving them free training and cloud certification. We just had our first batch of graduates last week, and where Jonah is also a mentor. So if you're interested in helping ulap.org, you have the link. Enough about myself. So normally when I talk about a certain topic, I always start with a why. Why do I want to talk about event-driven architecture? First of all, I really love stories. What does it got to do with tech? I love writing them. I love reading them. I love listening to stories. And for me, software development is nothing but just automating some of these repetitive stories of our day-to-day life. Some of the boring stuff in life we want to automate. That's just essentially software development. Event-driven architecture is a pattern which I think is very close to real life. In real life, we remember events, we react to it, we execute actions because of certain events. So like merging this tech into reality, the pattern of building a software into what actually goes on in the world is what resonates with me when I talk about event-driven. And I think it's really important to learn how to do this the right way. So to give you an example, right, a concrete example of a story. So, here in our planet, a lot of facts happen all the time. A chain of facts is basically the story of our existence. Let's take one of my favorite stories about my kids coming here to Denmark, enrolling in school. So here are my kids. So this is my son, Rain. He just finished gymnasium, doing his gap year, traveling a lot. And this is my daughter, Rayla. She's also in her last year, in a final year in high school. And these are just, facts. A few years ago, they moved to Denmark and enrolled in a school called Birkerød Gymnasium. And when I, as a developer, maybe peek into the school record of my son, Rain, here, it would probably say status graduated. Yahoo, he's graduated. But once upon a time, that status was actually applying. Then at some point, it got into accepted, and then go to registered, and then enrolled. But where are all these facts now in the record? I don't see it. When I go to his record, I just see graduated. What happened? We very well-meaning software developers just have overwritten data. We have mutated the database. So we have a very fundamental problem in the way we write software. So our stories are a bit skewed. It's like, it's lacking some of the facts when we just look at the records. So reading mutable databases is like reading a fairy tale that says once upon a time a prince met a princess and they live happily ever after, the end. So there's no story anymore, and that's why we're here, because I want to learn, or I want to teach how to use a chain of facts that has happened to design our modern application. So all right, then guess what is event driven? In a nutshell, it's an architectural style where, facts, like I have just mentioned, meaning something that has already happened, are pushed to one or more asynchronous processors to complete an entire business workflow. If you're following domain driven design, event driven architecture is, like I mentioned, also gives us that very succinct, ubiquitous language that can be understood from business to developers to data modeling down to writing our code. So you have events like, for example, let's use the whole story about enrollment. You have a event called student enrolled. As a business, a teacher will understand that. If I see that in my database and I see a record that says student enroll, I would easily understand it. If I have a command handler, event handler in my code that says enroll student, student enrolled, and name my methods like this way based on event names, then it would be easily understood. Event-driven is something you can use in a monolith or in process communication, but it really shines in distributed applications, because it decouples, the event producers from the ones that's processing the event. So what you call the processor components. So in cloud, in Azure, we like building it's essentially distributed, right? So the things that we build on cloud are distributed applications, unless of course you're just running on a VM. But why do we do that? Why do we build distributed applications on the cloud? Because we want primarily scalability and modularity. So we build them in separate components. But what do we do next? As soon as we started um, linking them or creating a direct communication between these components, like for example, you have an enrollment API and then a class API, then you start calling each other directly. Then we're breaking our goal of modularity and scalability. Suddenly we can't scale them separately. Suddenly they become a big monolith. They're in a single quanta. We can't have an SLA for one API to respond under, let's say, 500 milliseconds if the underlying dependencies that we have direct coupling with cannot guarantee that. So that's really essentially bad design. Event-driven can remove these dependencies, but it just also introduces some of these complexities. And I think that's one of the challenges in building event-driven, because it's very powerful, but sometimes it's hard to get it right because of some of the nuances. There are several use cases of event-driven application. Cloud is essentially, like I said, basically event-driven because you rely on facts such as a request increased in memory allocation reach or something like that, and then you dynamically execute an action like trigger a scaling of infrastructure. A lot of IoT solutions are also event-driven. Some gaming applications are event-driven, but where it's really important in enterprise apps, business apps, it's a little bit so. There are a lot of developers building enterprise apps that are event driven, but a lot of our enterprise apps, business apps, consumer apps are still built on the traditional, maybe RESTful APIs, or due to several factors. So some of these complexities for us developers are the nuances when building event driven. So I'm going to go through and some of them and I'm start unpacking it. So the first one is, this terminology, commands. Commands are not equal to events. So commands express what we want the system to execute when we want the system to execute an action. So enroll student, for example, is a command. And commands can either be invalid, and if it's invalid, we can't turn that into an action. Obviously, we need to check that. We can reply to an error, so the command did not happen. But valid commands can execute an action. You have a command handler. And once that action is completed, events are triggered. So events are triggered at the completion of an action. So when we say completed an action, it can either be a fail or succeed. It's still completed. Both are events. You have a failed event or a succeeded event, and you still need to handle that kind of events. So if you look at code, they're all just types, right? So command is a type that denotes the different data or attributes that describe a certain command. What do you need to execute a command? So for example, in this command register student, you need the first name, last name, address, emails, and program. And then somewhere down in this, actually in this sample code, I'm going to go through that in the demo. I'm using a library called Mediator, which helps with a whole command invocation without getting into dependency. How, if you have a lot of commands, suddenly your code becomes so complex, and the mediator will handle all the invocation of commands based on the specific signature. There are other libraries that does the same, and you can do without it, but just for simplicity we use this in the example. So you have every time a command is triggered, then you execute its handler. So inside a command handler, you will have some logic there. And then maybe to chain the commands, you can publish an event that has been completed. So for example, you register a student, you write your logic here, and then later on you publish a student is registered. So what does an event look like? It's also a type. So, but instead of describing what a command, what are the data for the command to execute, the event is a type that contains the attributes that describe the event that has happened. So in this case, student registered, we're only interested in knowing which student and what program, as an example. And inside your code, you probably also have an event processor or handler that, will be invoked by the mediator when this particular event is dispatched. And then you will also have a logic here. In this case, maybe you want to write that event somewhere else so that you can notify other components in your system that this event has happened, or you can update the state, or maybe call another command again. It depends. So that's the difference of, commands and events. The next nuance that I want to maybe have a look at is a sync request is not equals to event driven right away. So there's also a little bit confusion. So let's take this sample method, not asynchronous, but synchronous request. Like most of us are familiar with the request-based pattern. So it's really pretty simple. Like for this particular example, you have a UI that calls an API endpoint. Perhaps it's a RESTful API. Let's say this is the UI for registered student, and it calls the endpoint for registered student. But then your UI waits for a response from the endpoint. The problem with this pattern is that the API can take long. The API can suddenly receive too many requests, and then you will receive a timeout. So it's really not very performant. And so to solve this, we introduce what you call an asynchronous request. And there are different ways for implementing asynchronous request, but this one is what you would call a asynchronous with polling. So asynchronous endpoints typically uses a message broker, such as a queue. And the UI here can call the endpoint that writes to a queue. And then your handler actually listens to messages from the queue, which essentially can be, commands that are stored in the queue. And then this is the handler that picks up that command and does what it needs to do. For example, save some state in your database. And then this is polling because the UI can, instead of getting a notification from the status, it can call another endpoint. So whenever it calls this endpoint, it returns a different endpoint for you to be able to query either the status of the processing, or query the actual resource that you are trying to create here. So for example, student registration, you can look at what the student registration looks like, or you can look at the status of the process of student registration. So you can do two things. Is this event driven? Some people think, yes, this is how we implement event driven, but a little bit nuanced. Not really. Why? Because first, the message that you sent here on the queue is not an event. You did not trigger an event. You have sent a command. You just put it in the queue. So the calling component is also in a way a bit tightly coupled with the handler this way, because the calling component needs to be aware of how the command looks like. But this is one way of solving one problem. What is event-driven then? So there are different patterns for event-driven. So this is one of them. This is a broker pattern. Event-driven architecture can also still start from asynchronous request that dispatches a command. and then you have a handler, similar with with the previous one. But after the handler has completed the action, it will publish the event to an event broker. And then the broker notifies all the other components that subscribe to that particular event via push notification. So instead of calling, you can push it to somewhere. And then this will be the event processor will do further, logic, business logic, or do something else. So a broker pattern like this one means that there is no single process or component in the system that is responsible for orchestrating the entire workflow, responsible for making sure that, if it's a complex workflow with several steps, meaning each of these events can trigger several components in the system doing their own thing, and then all of those needs to succeed before a whole entire workflow like student registration completes. But there's not one single entity that takes care of that. So the event broker is simply a messenger. If something went wrong in one of the recipients, let's say there's a business error in one of these processors, you can publish another event on the event broker here, like another message, and other components can react to that. But you will not know if they have processed it well. So there's no coordination, and you might end up with a broken state of the workflow, and suddenly error handling is uh, is more difficult, and then it's hard to debug, and it's hard to kind of retrace and retrack your steps. The good thing about this is, of course, for certain scenarios, it might fit because then you don't have any dependency at all with any of the components. So you only need to have the event broker, but each of the other components do not have to depend on each other, making it truly modular. What if we really need something to make sure that the entire workflow that we are executing, especially if it's complex, either succeeds, and if not, we need to compensate for each of the for the issues and the errors that has happened, and make sure that we always end up with a healthy state in the system, not a broken state. So it's either a pass or a failed, but not unknown, because that's hard. So this is another event-driven architecture pattern, which is called the mediator pattern, or where you have a process manager. So it's like having if you have a family reunion, you always have that one aunt who gathers everyone and calls everyone and coordinates their schedule. So you have this mediator. So the mediator is the one that initiates the workflow, coordinate which events should be pushed to proper recipients here. It could have their own, queues there as well. And it also takes care of making sure that if one of the recipients here encountered an error, then it can send back a message maybe to the mediator, and mediator knows exactly what to do to rectify that issue. Maybe send send messages to other subscriber that needs to compensate or not needs to roll back, and make sure that all the end-to-end workflow works well. So in short, the mediator is aware of all the processing of events across different processors. And we still don't have service to service dependency. So this is still modular by design, but we do have a dependency on the mediator on one service. So it's a trade-off. But it makes the workflow more coherent, and that error handling a bit more efficient. So it's something that you need to think about when you're building event-driven applications. So another confusion in event-driven design, but what about event streaming? What about event sourcing? There's all sorts of these terminologies that has event on them, and we think, especially if we're new to event-driven development, is like which one is which, and it's important to know the difference so that we can make the right decisions. So an event-driven solution can have event streaming, can have event sourcing, but not necessarily. So the ones I showed before, those patterns, you can do with that, but without the event streaming or without event sourcing. So let's start with the event stream. So event stream or data stream. A data stream is is an unbounded set of data. Unbounded means it continuously grow as more events come. So it's just growing with more. It's an append-only log of events. And one characteristic of an event stream is that it has to be in order and it's immutable. You cannot change it once an event is committed on the event log. It's there, not forever. Some of the event stream services don't really keep your events. It can keep it for a certain period, but doesn't necessarily. It's not a database. But it's immutable means once it's committed there, you cannot change it. But it's also replayable. So if you're a subscriber to an event log, you can choose, first of all, which stream or topic you want to listen to. So which types of, let's say, events you only want to receive. You don't have to receive everything. And then you can also choose to replay some of the events from a certain period, which makes it really, really powerful. So stream processing means continuously consuming the stream of data at any point in time, and then manipulating it in real time. That's the key. You manipulate it also in real time. So manipulation can be filtering, transformation, aggregation. So event streaming is like a really sweet spot between the request response and batch processing. So we use batch processing a lot. Like in a traditional, let's say, analytics system, you read a batch of data to derive a new set of information, like for some reporting analysis. That's why it's called analytics. And then this batch data is of course deterministic. You can always process the same batch and you will expect to get the same result. But the thing with batch processing is you can't do it in real time. You have to wait, for period. So for example, your use case can't wait for you to only process the batch at the end of the day, and you have to really have real time information so you can react to it, but still need a deterministic set of this data. Then event stream is one of the best good things. So like in this example, it's the same as in the beginning. You can start with this asynchronous request, and your handler can still publish the event on an event broker. But sometimes a business step, let's say register a student or enroll a student, so that one particular step, before we arrive to that, there's a lot of things that can happen inside the user interface. Maybe the user starts clicking button, adding students, removing, deleting data before they hit the submit. And if you're the developer system and you want to maybe have some analytics around that, a lot of this minute granular activities of the user, event stream is also a good is a good pattern. So every single click I can put here, I can write to an event log, and then I can filter it, transform it, aggregate it. I can use it to, derive queries. So that is event stream. Next is what is event source. So all the patterns that we have been talking about so far is all about integrations of different components. But for event source, you're talking about like most of the time like the same domain, like only the student domain, and you're only interested in the student, for example, in the student entity. Event source is not about just the data flow, but more about the use of persisted facts to derive the current state of an entity. So for example, you want to derive the current state of a student or a student registration. So instead of overwriting the record in the database, you store an append only log of the events on your some sort of a persistence infrastructure, like your database or a special database for events. And then based on that, you can derive the current state of the student. So event source is also really great with when you're debugging, error handling, but it also has some drawbacks. For example, the event source can grow, and rebuilding an entity every time can be very expensive. So as an alternative, you can also choose to derive the current state and persist that in your read model. So remember again that publishing and subscribing to event notification is still event driven, even if you don't implement either event source nor event streaming. Little bit change data capture is not equals to event store. Change data capture is a feature of some modern databases wherein you can subscribe to a series of events every time record is created, for example, if it's a document database, every document is updated, or when a document is created, you get the feed and you can react to that. But I think it's very good for use cases where you need to do some data manipulation. Let's say you want to copy data so that it will be read optimized, or you want to archive data, but I want to stick to using change data capture event feeds for manipulating the database on the infrastructure level, but not really for handling business logic. So what are the different messaging infrastructure or services that we can use on Azure then? So for the different patterns that we talk about, so we have async requests, and you can use both a storage queue and a service bus, and both of them are very good with temporal decoupling. The difference is that with service bus, it's very good for using in high value enterprise workflows. And the key architecture for this tool is like for storage queues, you have, they're both pool style, but you have more, you can have more storage, of course, for the storage queue. It has a maximum 500 terabytes, but it can only guarantee at least once. It means you have to take care of making sure that if you receive duplicate message for some reason, that you need to be able to take care of that, for example, by making your APIs idempotent. For Service Bus, it's a bit more robust. You have more features in it, but it has less data. Like you have a limit of 80 gigabytes, but you can be guaranteed that at most once, that you only receive the message once. That means they have a good algorithm for deduplication. There's a feature by default for dead lettering, and you could use sessions if you want to make sure that the messages that you receive are in order within the same session. You can also use transactions and make sure that if you have, for example, you have published several, related messages in one go, more than one messages at a time, and one of them failed, that you can roll back all those messages. So they're atomic. And for the pub sub pattern, with the event broker, event grid is also one of the things that you can consider, but it is more for, it's a push style serverless event broker that has also a built-in retry logic in it. Like there's, I think by default, a 24-hour automatic backoff retry. And that lettering is not enabled by default in Event Grid, but you can enable it, but you have to select a storage, for example, where these messages can be put, messages in the dead letter can be stored, and then you can process it later. One thing is for Event Grid, it requires that all your subscriber has a public IP. So Event Grid is really also very good for publishing, notifying a lot of subscribers at the same time, millions of transactions. And then you have, Azure messaging and Azure messaging, so event stream. So you have Event Hub and Kafka for big data stream, like the event streaming that I have mentioned. So they're both support AMQP, and I put Kafka here because Event Hub, you can still, interact with Kafka via Event Hub. So for the event source, you can basically use any cloud databases, and you can use, for example, Cosmos DB. You can still use a storage or other cloud databases, SQL, to use as your event source where you can store your events. All right, so these are the different messaging components that you can use. I just want to show quickly how this looks like in code. Let's here. So I have my different services here. For example, I have students and classes API, and the whole point is that the student shouldn't be calling the classes API directly. So let me just run this. I think I am running a little bit out of time, but let's just make sure that I can show you this. So I have two APIs here, and what I wanted to do is that when I register a student, they will automatically be enrolled in a class. But I don't want this direct relationship between the student and the class. I want them to be decoupled. So first I start the student API, and let's say I'm going to, look at the students here. There are no students, so I'm gonna try to enroll a student. So let's enroll one student. But you can see right now, I have a student enrolled, but my classes API is still actually not running. So that's one thing that's really good with decoupling them. So classes API doesn't have to run. You can see I have a network error here, but because I have a service bus here, you can see I have my service bus here, and I can see I have a message still holding on to here. So I can, by the time I run my classes API, now you will see that if I go here, I want to see that I still have that student that I registered earlier on enrolled in my class. So you can see I have all these classes, and this particular one student is enrolled. So that's 3A19. So if I add another student here, let's say Jonah, and I go to classes, Jonah will also be enrolled in this particular class. So that makes them decoupled. So I can share the link to my GitHub for you to see how I wire up everything. So the student is the one that actually writes to the event grid. The event grid is configured to send the messages to a service bus, and the service bus is what this classes listens to. So I have implemented a background service, a hosted service on my API to be able to listen to and process to these services. And yeah. So, what are the pitfalls that we have to really consider? If you have to think about event schema, effectively ones, idempotence of your APIs, how to handle ordering, how to do error handling, distributed caching, and most important, security and privacy, because these are data going through the wire. So make sure that all the data that you store between different services and event brokers and other messaging services are of course secured, and that you don't have, you're not violating GDPR. We learned a lot about the different event-driven patterns. You can learn more. This some of the books that I want to recommend if you're interested more in event-driven design. There's a good article, Choosing the Right Azure Messaging, and there's a book called Designing Data-Intensive Application by Martin Kleppmann. And some of my favorite books on architecture is called Fundamentals of Software Architecture. So thank you, Azure Servia, and thank you for joining my session today.
Thank you very much for your presentation. It was really, really good presentation. I enjoyed, even though I'm not from dev side, I'm from upside. It was really interesting for me. And potentially, I would be worried because you and Joanna put some standards of presentations in the Azure hearing, but I'm not worried because I know who will be next speaker. So I'm
Yeah,
pretty sure that would be a great, great event. And
thank
I
you.
have one question for you. Uh, if I missed, forgive me. That info, what is about from the pricing perspective if you want to move some old school application to event-driven sourcing system or whatever?
All right. So, in my experience, especially when I'm just starting out with event driven, maybe I want to migrate a small piece of my application and just test out the concept. Then I always start with the Azure Storage Queue. That's probably your cheapest option. And also, really determine what do you really need. What is your SLA for your event driven application? Do you really need effectively ones, or do you really need ordering? Do you need sessions? If you don't need these things, maybe you can do away with a cheaper option like storage queue. So that's my default answer, but then there's a lot of things to
Yeah,
consider, of course.
why I ask that because first time when I had any kind of interaction with from the architectural side with event-driven system, maybe 6 7 months ago, and then when we started to analyze what potential cost would be for the client because they have a pretty old application, we found that their current system, if it's migrated to Azure, will be 6 times more expensive than event-driven. And it was really surprising. That's really possible. So we run calculation couple of times, put it on billions of actions to all of those resources. And yes, we are still way below their calculation. So that was really surprising for me.
Yeah, so there, you have so many options, and of course, there are other open source event systems as well, or messaging. But then, there's, you don't pay for the license, but you would still pay for the infrastructure. You would still pay for the people who would make sure that this runs. So you really need to consider these things when you're choosing the right service.
Okay. Uh, Also, again, thank you very much for participating. I hope we have chance to meet in person on some events, and so maybe we will organize this kind of event in person. Uh, and that's it from my side. I hope you enjoyed as well.
I did. Thank you so much. Have a nice evening. Looking forward to the next sessions.
Thank you very much, and we will take a couple of minutes break.